Good morning. My name is Brian Wasserman. I'm construction management faculty with Minnesota State University Mankato. I'm working with Primavera P6 software, and today we are at the very beginning. This is level A. Our first topic this morning is the definition of CPM scheduling. Let's talk about the history for just a brief moment. Most of you are familiar with a Gantt chart, named, by the way, after Henry Gantt in 1919, and that's the same thing as a bar chart. So in a Gantt chart, you will see lines across your page, and each of these represents a task. Task A, task B, task C. The lines represent a duration, typically done in days. So this line might be 5 days, this line could be 4 days, this line could be 6 days. In a bar chart or a Gantt chart, the lines are not connected, so that if task A is late and actually gets done here, task B is not affected on my bar chart. Now in the MnDOT world, sometimes only bar charts are required for different projects. And a bar chart then, as it gets updated, each individual task would also need to be updated because task A does not affect task B. So this type is labeled Gantt chart or bar chart. Not much changed in the scheduling world from 1919 with Henry Gantt and the creation of bar charts until the 1950s and the introduction of CPM scheduling. In the 1950s, with new computers, old mainframes we call them, came DuPont, who scheduled a chemical plant in Kentucky using the old method and scheduled the same chemical plant using the new computers. At the end of the day, the success of the computerized scheduling showed that it was well worth using a different method of scheduling. And the computers since then have been used in scheduling. So CPM scheduling, critical path method, has become the standard of operation for scheduling ever since. And there are two parts on the critical path method. The most important thing is that if I have a task A and then it is connected to a task B, that if task A is delayed, then that affects the beginning of task B, and task B can't start until task A is completed. The tasks that are connected are part of that critical path. So CPM, or critical path method, has been around since the late 50s. The United States Navy did what they called the PERT method, Project Evaluation and Review Technique. It does the similar thing as the CPM. They drew boxes. And the boxes were divided up and had pieces of information in them, but essentially it's the same thing, that until this task is done, this task can't start. So it developed what we call a critical path. The critical path tasks then have a few terms. One is called predecessor. The other one is called successor. The predecessor being task A in this example, the successor being task B. That the successor can't start until the predecessor is complete. So we have the terms predecessor and successor. We'll use those regularly in the Primavera P6 computer world. There's another concept, and that's called lag. Task A, task B, sometimes there's a period of time in between those two. And so if task B has to wait a couple of extra days after the end of task A, there would be a period of time in here that would be called lag. And then task B begins. Most scheduling is done using days. So our tasks are in whole days, not half days, not hours, not minutes. Sometimes if we're doing a shutdown project, the tasks might be in hours. But most of them are in days. Not all tasks, though, actually take up time. There are times that we want to put a task in as what's known as a milestone. A milestone is defined as a 0-day duration task that is a marker in my project. Typically comes in as a symbol like a star or a triangle and will mark an inspection or a closing point of some part of the project. So the term milestone comes in. This might be the end of the removals, for example, on a MnDOT project. We also have the term called float. There are two kinds of float. There's free float and there's total float. The tasks that are on here that are not critical have some float, which means they could be delayed without causing the entire project to be delayed. So the most important type of float is called total float, and that is the amount of float that a task could have without delaying the entire project. Free float, the other type of float that we'll talk about, is the amount of time that task could be delayed without delaying any other tasks. But in MnDOT and on our work, typically the most important kind of float is total float. And then we have the term near critical. So as the total float is used up, then it almost becomes a critical activity, and so we'll use the term near critical. And that term near critical is defined by how many days of float. So less than 5 days, less than 10 days, less than 15 days makes a near critical activity. Next, we'll talk about different types of schedules. In submitting schedules for MnDOT, there are a list of types. The first type is a preliminary schedule. A preliminary schedule is a negotiation between the contractor, who already has the job, and the resident engineers or project engineers from MnDOT who are reviewing the schedules. They are very basic. They are set up so that the structure would be there, but they are not a working schedule. When the preliminary schedule is accepted by both parties, it becomes a baseline schedule. The baseline is considered to be your original target. It's the list of tasks, the order of tasks, and the duration of tasks that everyone has agreed this is what we will do. As the project moves along, there are times where, let's say, it rains for a week straight and the work is delayed. Then there will be a recovery schedule. The recovery schedule again becomes a negotiation between the contractor and the MnDOT supervisors, saying, and here's how we will bring this project back on track so that it doesn't continue to slip and the project just be delayed indefinitely. So we really have three basic kinds of schedules. There are others mentioned in the MnDOT spec, but at this point in our introduction, we're not going to cover those. We'll cover those in level D. For the remainder of level A, we are going to focus on a small bridge project and the activities and tasks and relationships that go into creating a small bridge. We will keep things simple, keep things direct, and do the best we can to give good, clear definitions for the terms, because the terms, the language we use in scheduling, is really vital to success as a scheduler, as a reviewer, as a MnDOT employee working with any of the contractors on scheduling issues.